The recording has started. You can proceed. Thank you so much.
Thank you. Hi, everyone. Let me share my screen. Okay. Are you able to see my screen? Can you let me know?
Yes, Sweta. Yeah, your screen.
What do you see on the screen? Do you see the presentation?
It is on. Yes.
Okay. All right. So let me start. Okay. Hello, everyone. My name is Shweta, and I'll be today talking about securing your Azure services, PaaS Azure services with Azure Private Link. So before we start the discussion, I would just like to understand if any one of you would like to share what is it that is required to be considered when you are working with PaaS resources in Azure or in any cloud for that matter to ensure the security of those resources. Any answers from you or anything that you think that is very important to consider? Oh, okay, let me just I'll just stick to I wanted it to be a little more interactive, but I guess it's a little difficult to have that type of interaction with online sessions, but let's see. So what are we talking about here today? So today we are talking about Azure Private Link. Azure Private Link enables, so this is a basic definition sort of Azure Private Link, where Azure Private Link enables you to access Azure PaaS services, for example, storage account or SQL database hosted on Azure, or even Azure hosted customer-owned services over a private endpoint in your network. Now, when you're building any application or any service that's built on top of cloud, then what are the things that you would think about in terms of securing that service? You would think about who wants access to the service. That's the who part. What are we securing? Is it what sort of data? It's application. What are we securing? What is the confidentiality level of that data, if it's data or application? And how should people be accessing this particular application or service? So when we talk about these things, these are very basic security aspects of your service, right? So then so people have just talked about enterprise access model, or accessing, maintaining the role-based access, or even privileged access to particular resources. So there is a access control available in every cloud provider's stack, right? But why do we have the need of securing the services at network level? Why do we want if anyone wants to answer, that would be great. Not able to hear properly. Mandeep, is that a problem?
No, I think Sweta, hear properly.
Okay. All right. So maybe it could be an issue with Vaishnav. Sorry, Vaishnav. Yeah. So then, why are we trying to access resources over a private network? What could be the reason? So somebody has just mentioned zero trust. Yeah. So that's exactly what could be one of the answers. Like when we talk about zero trust, that means that we want to always assume breach and not allow anybody access and always validate access, right? That's what zero trust model means. I think people are talking about that as well. So when we talk about zero trust, let's just try and take an example. So let's say there is a cancer research lab, right? So, and they have a lot of data lying around about their research, which is highly proprietary data, highly confidential data, which they would love to protect. They would like to patent it in future. So they want to have that secured, right? So what is their what could they do is just they keep it on their server in the company and just lock it down, access to that server. But if they want to have the benefits of cloud, they would probably want to put their research data in cloud as well. But they still want to maintain that access control and that secure access to this data in cloud, right? So so let's say who probably would potentially who are the people that would be working in this company. There could be somebody from HR, there could be a data engineer, there could be a data scientist, different sorts of people, right? But there are some people that would definitely need access to the data. Some people would need some level of access to the data, not entire higher level of access, maybe not writes, reads, sort of access, and some people would be completely blocked from getting access. So this is like a role-based access. When we talk about this, like Susan from HR, for example, shouldn't get access. Mary is a data engineer. She might get some level of access to play around with the data when she's confident in the pipelines and all of that. Rachel, for that matter, is a data scientist. She is working with data, so she would need access to the actual data. So in this type of scenario, role-based access control comes into play. But let's say we ensure that proper RBAC is in place, and now only Rachel has access to the whole data with the proper level of RBAC. But is that enough? That's the question. Even if let's say we are using a storage account in Azure to store all of this data, and there's encryption address, encryption in transit, all of that is configured, HTTPS and all of that. So we are sure that when Rachel is accessing this data over the internet, it is happening over HTTPS and the data is encrypted. So maybe it's okay, right? What's the problem? It's encrypted, so there's nobody trying to access that, would get access to that encrypted data, even if they are sniffing around the network. But that's not the only thing. Even if you secure data at the application layer with SSL and all of that, there's still information like the sender's information, the location of the sender, IP of the sender, that all of that data does not get encrypted, right? There's network level security comes into play over there, that you're trying to access. If you ensure that this access happens over a VPN, then it establishes an end-to-end tunnel between the consumer and the service, so that we're sure that the entire traffic, including identity of the sender and location, all of that is encrypted, and that complete traffic is isolated from the outside network. It's not even in as part of, is seen outside that particular tunnel. So I think it's so that's why it's important to have that network layer of security when it comes to very sensitive data or highly confidential data. So I think that sort of establishes the need, but I still just wanted to bring this point home, that when we are talking about this, we are talking about defense in depth, right? Somebody just mentioned zero trust model. So when we are assuming breach, we have to ensure security at every layer, like physical security. That means wherever the data center is, you would ensure that the data center is protected physically, the servers are protected physically, then identity and access, maintain the RBAC, ensure that there's a proper perimeter placed around your service with proper firewalls in place, wherein you ensure there's no DDoS attack, and all of those parameters are considered. Network layer which is what we will be talking about today. Compute, application, data, like ensuring that wherever data is at rest, it's encrypted. Application, whenever data is in transit, it's getting, it is traveling through the application layer, which is the content is encrypted through HTTPS. So all of that, basically, every layer of that access to that application, we are ensuring that there's some level of security implemented. So it becomes very difficult for anybody to get inside or have unauthorized access to the data. So now how? So we talked about the what, we talked about why network layer, and now let's just focusing on Azure. How do we ensure that the Azure PaaS services are protected at network layer? So when we talk about network layer, I'm not from the infra background, but when you're configuring virtual networks and VMs and all of that, when you're configuring the infrastructure, it's with VMs you can view that there's a network security group, there's firewalls, and on the virtual network you can protect VMs with NSGs and all of that. Now with Azure PaaS services, we don't have access to the infrastructure where the service is hosted, right? So maybe it's hosted in the data center. We don't have access to that, and the point of PaaS services is basically we not having to worry about it. But obviously, not having control over infra shouldn't stop us from ensuring that it's secure. So when PaaS services are provisioned or offered to the clients, it should also come with some level of security settings. So there is RBACs, there is access control lists. If we talk about storage account, there's ACLs as well. So even granular level of access can be managed on the service level. If we talk about storage account, same with SQL database. You can manage access to a data with SQL database rules. Roles, different levels of security within the resource. But when we talk about the networking, how do we ensure that nobody outside my private network or outside this network, virtual network on Azure, or outside this on-premises network, which is connected to Azure network, gets access to this service? So that's what we are going to talk about here. How do we achieve that? So before moving on, does anybody have any questions? Let me just check the chat. Any questions till now? Okay, I guess not. So let's just go back on the how, right? So what are the options? So what we can do potentially is punch holes in the service firewall, right? So every service has a firewall setting for it, and what we can do potentially, when let's say I have created a storage account and I want to just upload something to it. When I'm doing that, I could just say that, okay, just whitelist my IP so that I can I can just go to the storage account UI and upload, or go to Azure Storage Explorer and upload a file and be done with it. So that is one way, but it's not obviously a scalable way. Because there could be multiple clients who would want to access this storage account when it's being used. There could be multiple VMs, there could be multiple networks, small virtual networks that would want to connect to this service. So punching holes is definitely not a scalable option. It's just an access control list basically, and that list also has a number limitation, like how many roles can you have? I think it's 128 or something. So that limitation is obviously there. So that's not, and again, whoever has good level of access to the service could also potentially go and alter these settings as well. Or remove a private IP or add some public IP or things like that. So that's not a very foolproof way. It's probably just for testing and development purpose that you could use this feature. Then there is an option of service endpoints. So we'll take a look at those in with detail, and then we'll talk about the private endpoints, which I think will be the most secure way of accessing your resources. So let's talk about service endpoints first before we go to private endpoints. So every Azure service, many of them have this service endpoint feature enabled. So when you want to allow a particular service to be accessed only via a particular VNet, what you would do is enable storage service endpoint. Let's just talk about Azure Storage in this example. So you would basically enable similar service endpoints can be enabled for every different service, like SQL and app service or other PaaS services on Azure. So let's say you enable a storage service endpoint on this VNet. So then this virtual machine would be able to access the storage account. We'll see a quick demo of how it can be done in Azure portal quickly, but what is happening over here, I just want to quickly understand. I want you to understand this is that when we enable this sort of setting on storage account that allow only VNet 1 default subnet traffic to access the storage account. What happens is the storage account service blocks all the traffic from the internet, first of all, so nobody over public nobody outside of this VNet would be able to access the storage account. That's one thing that happens. And so there's basically some sort of a validation layer on the service wherein it will identify that the packets coming from this particular subnet with a virtual network identifier. Okay, so this is coming from VNet 1. Okay, then I will allow it. So this packet is coming from VNet 1, I will allow it, and so on. But if that packet comes from some other network, then it won't have that identifier on the top of it. So it will say that, okay, you don't have the VNet 1 identifier, so I will not allow you to get inside. And then eventually the person who's trying to access would get a 403. That's forbidden. So you're not allowed. So I know who you are, but you're not allowed to access this. So that's how the storage account service endpoints work. So whenever you enable a specific service endpoint on a subnet, every packet that goes out of the subnet is highlighted or is marked with a virtual network identifier. And that identifier is how the target service, that is the storage account over here, identifies that, okay, this is something that I want to allow, and this is something that I don't want to allow. So it's, again, a little bit of ACL kind of an implementation, a little bit at the lower network layer, but it's still not establishing any private connectivity between these two services. This is still flowing over the internet. It is still a public route, and it is going over Azure network, Azure backbone network, but it is still over the public network. It's not a private connection, right? So that's what is service endpoint. So let's just quickly see service endpoint creation. Does anybody have any questions till then? Think about anything? It's also the same as internet connection. No, Azure Backbone Network is basically, it is Azure's network, to be put simply. So it is ensured that it's still flowing from one Azure endpoint to other Azure endpoint and not going over the public internet. But it's not the same. But it is still not a private network a private connection between the source and the target. So quickly, let's just see how you can enable service endpoints. So if you go to a storage account, go to networking. Currently, the setting says that it's enabled from all networks. So every service can access this particular storage endpoint, right? So for storage, there are multiple endpoints. If you go to the endpoints over here and just copy this blob service endpoint and do a quick DNS lookup of that, you would see so you would see that there is a public IP associated with this endpoint, right? Which basically is a public interfacing endpoint. Now, if I go to networking and I go to enable it from only selected virtual networks, I would just add as existing VNet 1. I'll add a subnet. Will also enable a service endpoint on that particular subnet, because there's so you can see that it doesn't have the service endpoint enabled, so it might take 15 minutes to enable it. So you just click on enable, and then it will enable the service endpoint, and it will add that that VNet subnet as a whitelisted network in this, right? So anything that so here you go. So you've added a default subnet. So any traffic that comes out of this particular subnet will now be tagged with the identifier of that virtual network. And that is how the storage account would identify that, okay, this is something that I'm allowed to let in. So I will let in this traffic. Whereas it will not allow me maybe to access it from my particular machine. So if I go to containers over here and I try to access this, it will say that, okay, you're not allowed to access, because you will have to either whitelist your own IP. That's what we talked about, punching the hole in a firewall by saying that, okay, allow my IP to get inside. I just have to try and access this particular container or particular blob from default subnet, from the VNet 1 subnet that we just whitelisted, right? So that's how. So when I tried to access it, basically knew that, okay, I'm not coming from VNet 1, so I'm not allowed. That's how it's. That's how the service endpoints work. Okay. Now, if we let's just quickly go towards the that's about the service endpoints. If we have any questions, let me just quickly check. Can you zoom in a little bit when you? Okay, sure. Yeah. I will do that. 20 minutes. Okay. Quickly going to the private endpoints now. So now what are the private endpoints? So before going to the private endpoints, I'll just quickly talk about what Azure Private Link service in general is. So it is basically a service offering from Azure to allow any services that you develop on Azure to be exposed to your customers over a private connection. Now, let's say you build a very cool app which is hosted on a set of VMs in your Azure network, and you want your customer to use it. So what you will probably do is you'll give them some sort of you'll create a custom domain. You would put up probably a load balancer in front of your VM, so maybe a single VM, and you'll just give custom DNS to it and provide it to your consumers. But that makes it available to everyone, right? Everyone on the internet could probably go and access your application, and you might not want that. You might want only your customer to be able to access it, and only over a private net connection. Then in that case, what you can do is you can enable, you can ensure that your service is first of all running behind a standard load balancer in Azure, and then you can add a private link service. You can attach a private link service to it, which will allow your customer to create a private endpoint against your service. So we'll revisit this once we talk about private endpoints a little bit. But that's what Azure Private Link service is. And private endpoint is nothing but an implementation of this. So this is how it will look like. So this is something that you have built over a set of VMs. There is a standard load balancer, and you have attached a private link service. So now your customer, who's in probably another Azure tenant in another Azure network, trying to access it, can access it over this particular private endpoint, right? They can create a private endpoint pointing to your private link service. So when we talk about storage accounts or SQL or app services being able to access these services over private endpoint, what has essentially happened is Azure has created a private link service for you to access. So in that scenario, we are basically nothing but the consumers of the service as storage account, and Azure is the provider of the service. So they have used Azure Private Link service to expose the storage service or the SQL service to us via a private endpoint. So we can then, which enables us to create a private endpoint on that particular service. Okay. So what is the private endpoint basically? So private endpoint is nothing but an interface, a network interface, which gives a private IP to your service. So then you can use that within that virtual network. So any resource within that virtual network, like when you create a virtual machine, for example, in a virtual network, it gets a private IP, right? And all other virtual machines within that network would talk to that particular to that VM using that private IP within the VM. So that's how similar to that, it will just be another endpoint, another network interface that a VM could talk to over a private connection. Similar as if that storage account has been brought into your VNet. So it just gives that idea that that storage account is inside your virtual network. What has happened is it just has provided an interface to that service within your private network. So the network interface connects you privately and securely to the service that is powered by Azure Private Link. So storage account is a service that is powered by Azure Private Link. SQL is a service that is powered by Azure Private Link, and so on. And by enabling a private endpoint, you're bringing that service into a virtual network. So now what happens under the roof, right? So let's just quickly see that. It's actually an interesting thing to see when we study or read about private endpoints. You would just read how to enable it and all of that, but there's a fun thing that I'd like to show you. So when you want to create a private endpoint, what you do is you will disable all the traffic. You would go to private endpoint connections, create a private endpoint quickly, name it storage demo. What was saying target? So I am creating it for the blob service specifically. Just put a pin in this DNS integration for now. We'll talk about it in a bit, and then you create the private endpoint, right? So basically, when you create a private endpoint, that's how you basically create it. It's not that difficult. So now any service within this particular VNet1, would be able to access this particular storage account using a private IP. Okay, and with the help of the DNS integration, what happens is with the help of DNS integration, what happens is that the DNS associated with your storage account is mapped to that private IP. So that when you try to resolve the endpoint, the blob, so we have created a private endpoint for the blob service, right? So when you try to resolve the private endpoint of the blob service, what it'll do is it'll now let's quickly see. We saw that when we created a service endpoint, it was pointing to there was an alias record here, which probably Azure uses internally. Yeah.
Sorry, there is a comment like, when you are doing the Azure portal, if you zoom in a bit.
Oh, yeah. Sorry, I forgot about that. Yeah. Sure. Is this better?
Yes.
Okay. So here the private endpoint is created, and if you go to DNS configuration, you would see that there is a private IP associated with it, right? And this is the FQDN of the blob service endpoint. So now if I go and do a dig of this, right, what would I get? Yeah, so you see a new CNAME record, that's an alias record, has been added to this particular DNS, right, which is pointing as private link. Okay, so what is happening over here is it created a CNAME record so that when anybody from the private network is trying to access it, okay, it'll see that, okay, there's a private link associated with it. I will go and access it through that instead of the public IP. So then what will happen is we go back to so, and another quick point is that when a private endpoint is created, right, to all the virtual machines within that VNet, let's say I have a VM1 created over here. If I go to the NIC, that is the network interface of the VM, and if I go to effective routes, okay, VM1 is stopped. I forgot to start it probably. But if I go to that routes, right, there's a /32 address that gets created with a service tag called network interface. So now whenever VM1 is going to try to access this particular private endpoint, what will happen is it will see in its effective route that there is a /32 route pointing to this VM when it resolves that IP, and it will use that route to access the private endpoint, to access the Azure service, basically. So I've started it. Let's see if it turns on. I'll talk about it. But going back to the DNS, so yeah. So when we configure our DNS setting, it creates a private DNS zone. Basically, which is nothing but a resolution of your private endpoint, this private link endpoint to that particular IP. So it connects this IP with that private link DNS. And existing Azure services already have a DNS configuration for a public endpoint, as I showed you, right? So they already have, so Azure DNS basically has this CNAME record created already for this endpoint with this private public IP. And how does my VM or anybody know that, okay, that's the CNAME record or whatnot, is when we check, if we check the VNet, if we go to DNS servers, so there's a default Azure provided DNS, which is queried when anything with a Azure domains are queried. It'll use Azure provided DNS, and we'll try to find out whether there is an entry with this private link DNS, right? So I asked you to put a pin in that DNS zone. So if we just quickly go to the endpoint, okay, and the DNS configuration. So this is the private DNS zone that has been created, and there is an A record pointing the storage service to this particular. This is just nothing but how a normal DNS would get resolved. It's just that it's restricted to this particular private network. It's a private DNS zone. So it is resolving this storage endpoint to 10.1.0.5. Right? So when go back to the thing. Okay. So when you are basically a client VM is trying to, the VM1 is trying to access something that is blob.core.windows.net, it will redirect its query, because this VNet says that go and use the Azure provided DNS. It will go to this particular Azure provided DNS. It will then pass on this query to Azure's recursive resolver, which will see that, okay, there is a private link or CNAME record associated with it. So let me see if there is a private DNS zone, which is associated with this, which will give me the private IP, which then you can see that there's a private DNS zone with private link.blog.core.windows.net, and it has the entry effectively of this particular storage account name with this particular IP, right? So it'll give that back. Azure DNS will give that back with a private IP, and that's how finally the connection will be established with the storage account. So that's how the DNS. So that's what is happening under the hood when the private endpoint thing is, private when a VM is connected to storage account via private endpoint. Okay. So let's say quickly I'll tell you, like, if it is happening over from on-premise network to Azure VNet, and let's say there's an express route connection, then what would happen is you would configure a local DNS server that would point your VM to a DNS forwarder within your Azure VNet, which would then effectively point it to Azure provided DNS, and the whole thing would repeat, right? So what happened is from here, quickly open. So from here, he'll try to look up in the DNS server. DNS server will have a forwarder which will ask it to use this. This DNS forwarder will point to Azure provided DNS. Then Azure provided DNS further would look up the private DNS zone, and then the connection would get established. Now this would require you to create a VM within your create a VM within your Azure VNet, but there's also a Azure service called Azure Private Resolver, DNS Resolver, which would do that as a service instead of you creating and configuring all that VM stuff. So you can just ensure that there is a Azure Private DNS Resolver created in your VNet, and your local DNS server from on-premises is pointing to Azure Private DNS Resolver when it tries to access storage account. So that's how you would do that. If there are any questions still now. Otherwise, I'll just move to
Shweta. Is question from Bipul: how proxy and private endpoint based communication differ?
How proxied and private communication. So your question is basically if you have a proxy created in front of your private network, is that what the situation is? Can you explain it? I have 10 minutes. So I just wanted to show a quick nice question, feature or nice gotcha there. So maybe I'll answer this question a little later to understand it better as well. So let me just quickly go to inspection of your firewall, inspection of your private endpoints. Now, we talked about the /32 routes, right? Now, let's see if my VM is turned on, maybe it will show you that route. Go to routes. Okay, so here, so this is my private endpoint IP, and it has created a effective route of /32 with a service tag called as interface endpoint. So this is a service tag that is internally used to represent a private endpoint. Okay. So now, because of this particular peculiarity of how private endpoints manifest themselves in a network, what happens is if you want to let's see. Now, first we'll talk about if you want to ensure that the traffic to a private endpoints from any network basically is routed through a firewall. What would you do is you would ensure that what you should ideally have as
Hi, Sweta. I think we lost you. Looks like some connection issues. Let me check with her. All right. Meanwhile, Sweta is joining. Please, if you have any questions, feel free to drop on the chat window. So once she back, we'll ask her to answer that.
I think I dropped and I didn't realize. I don't know where did you guys hear it till. Um, Mandeep, are you here? Am I online?
Yes, Sweta. Now you're back. Yeah.
Yeah, I don't know what happened there. Um, okay, so I think the time is over as well. So maybe I'll just.
Take some extra time as well, since the next week speaker will join 5 minutes late. So yeah, take
Okay.
it. Take up 5 minutes, yeah, extra.
Yeah, I'll just then quickly jump onto the demo.
Sure.
Yeah. Let me know when you can see my screen. Are you able to see my screen? I think you are. Okay.
Yes.
Yeah. Okay, so as I was saying, if you're trying to access your private endpoint from on-premise network and you want it to go through Azure Firewall, then you need to ensure that your basically you're creating a /32 route for every private endpoint in your subnet to go through the Azure Firewall. And that is because of this particular implementation of private endpoints, wherein they create an interface effective route of /32 for every private endpoint. So what happens is, let me show you that I have created this firewall, and I'm saying this is my on-premise network 10.4, and this is a VM that is connected to my hub, and this is another private endpoint subnet that is connected. So let me show you this quickly. So here is my on-premise network, which is connected to hub VNet, where there's a firewall which has a deny rule specifically to both of these networks, okay, to the VM as well, to the private endpoints network as well. Right. So if you see this, to Azure VNet, it is saying deny. To private endpoint also, it is saying deny. Right. This is the /16 root. So this is entire. Sorry, this is /16 root. This is entire private endpoint network, and this is the entire another network which doesn't have private endpoint but has a VM. So if I log into my this on-premises VM, right? So I have an on-premise VM here. Bring that over here. All right. Right. Okay. So this is my on-premise VM. So if I say that we have denied traffic towards the one spoke which is having VMs. So this is a private IP of the VM in one spoke. That's a AZVNet spoke. And if I ping it, it is denying that traffic, because I've created a policy that says you cannot go to 10.3.0.4. But even then, same rule has been created for 10.5.0.4 0.0 as well, which is where my private endpoint is. If you want to see that quickly, this is my private endpoint, right? This is where my private endpoint for storage account is. Now, even though I've said that any traffic going towards 10.5 should be blocked, so if I had a VM in 10.5, it would get blocked. But since this is a private endpoint, it doesn't get recognized as 10.5.0.0/16 route, but it gets recognized as 10.5.0.4, that is a specific IP address /32 route. And through that, it is still accessible, even though I'm saying that, all traffic to that subnet or that network should be blocked. My blob is still accessible. Now, if I go to the firewall policy, both 3 and 5 are denied. But if I go again back to my VM, this is actually pointing to 5, if we want to see that quickly. If I do a lookup, it is pointing to 10.5.0.4. Now 10.5 has been blocked. The entire range is denied. Still, I'm able to access the private endpoint. So if you want to ensure that your private endpoints traffic towards your private endpoint is going through the firewall, then you not only have to ensure that all traffic towards that subnet goes through the firewall, but you also need to create specific route /32 route. That what you'll have to do is you have to create another rule that would say that 10.5.0.4/32 is allowed, and then also create a SNAT rule of that. So that's an inefficient thing to do. Basically, you could have hundreds of private endpoints in your VM, and then you'll have to create all of those rules, and there's a limit on the number of rules as well. Then Azure has tried to remediate this problem and quickly came up with a solution, wherein what you can do instead is, if you that's my if you go, this is my private endpoints VNet. There is they have created a setting on a subnet, which if you enable, it will tell the subnet to respect the routing instead of using that /32 route. Please respect this route. So if I'm using this through route tables, you can also use it, create that rule through NSG, but I've used route tables. So if I enable this particular setting called private endpoint network policy for this private endpoint subnet, then it will take some time to take effect. Once it's saved, I will be able to access the private endpoint. Yeah.
Shweta, sorry to interrupt. This is Mandeep.
Yeah.
So
yeah.
Have the next session, next speaker.
Yeah. Sure.
Line. So if you can
yes. Yeah, I'll just quickly summarize. So now if you see over here, it'll time out and it'll get blocked. It's still waiting, so it'll take time and it'll get blocked. It's not able to access the blob anymore because I told it to respect the routing instead of respecting that, instead of leaking out. Yeah, it is not able to reach because now it is not able, it is following that deny rule and not using that /32 route. It is following the deny route that we have configured on the firewall. So basically, to summarize quickly, use private endpoints over service endpoints to ensure a higher security. Understand how private DNS resolution works so that you can properly secure and properly ensure access to your private endpoint resources, and to inspect or filter traffic to your private endpoints using a firewall or NSG. Turn on the private endpoint network policy setting on the subnet. So that's some key takeaways to ensure the traffic to your private endpoints is also secured via Azure Firewall. I think that is about it from me. Maybe I can hand over to the next person. Thank you. I will stop sharing. Yeah. Thank you so much. Yeah, I'll check out the questions and answers in the chat if possible. Thank you so much.
Great. I think the next session from Tushar. Tushar, now the stage is yours.
Yeah, perfect. And if you can hear me loud and clear.
Yes, I can hear you loud and clear.
Perfect. Let me just quickly share my screen.
We can't hear you, Tushar.
Okay, if you can hear me, can you just acknowledge in the chat, or Mandeep? Can you hear me?
Yes. Now I can hear you. Thank you.
Oh, perfect. Apologies, my Teams crashed at the moment I shared. Okay. A very good morning, good afternoon, good evening to everyone from whatever time zone that you're joining in, and I hope you're enjoying all the sessions around various security topics and India Cloud Security Summit. And basically, today we are going to see a couple of things from my side as well around a few new security things that is coming in within Entra. So without any further delay, I'll start with my session. So basically, to introduce me, basically, I am Tushar Kumar, Cloud Security Lead at Kodak Ireland. I have been talking about a lot of security as well as cloud infrastructure topic, mainly focused with Azure, and you can find all of that on my blog, and as well as I blog about a lot of other stuff as well, which basically comes out around the new technologies that is coming in, and as well as if there is any real world problem scenarios that we see in day in day out of. Okay, so moving along, today's session is the title and I'll tell you where the title is coming from, and right. And one of my customer, and I was talking to them, and they were like saying that okay, we want to make